Assalamualaikum to my lecturer. My name is SUHADAH binti SALEHIN and my friend name is MUZANY and Syahirah binti Razali. So today we will present about recyclable material classification by using convolutional neural network. For the introduction, as the country grows, the number of people moving into the city increases, and consequently, the volume of solid waste generated also increases. It can be seen that most people take for granted of recycling, which is able to save resources, prevent pollution, and contribute to public health. The recycling process is the determinant of a better future to avoid pollution that can change the world landscape and affect the life of future generation. And one of the methods we can do is managing the recycling waste by recycling. Some are aware that they bring home all the recyclable material and segregate them into different bins around home, public places, or office. Recycling helps minimize the amount of waste, and using automatic classification machine of waste could further reduce labor cost of recycling tasks. CNN is a vital technology to the waste sorter machine, and CNS consists of input layer, hidden layer, and output layer. CNN is specialized type of neural network model designed for working with 2D image data and have proven that CNN is very effective in areas such as in image recognition and classification. So in this assignment, we will use CNN method in order to detect PET bottle and can. So now I will proceed the presentation to my friend to present the methodology. So for the demonstration, firstly, we mount the Google Colab into our OneDrive. So second is feed the dataset directory. For the third step is create, train, and validation data directory. So you can see when we run it, the can train length is 156, the PET bottle is 310, the length for can is 77, PET is 133, and the test length is the image of PET bottle and aluminium can that we are taken, which is 3. So for the fourth step is input the relevant library. So next is training the model, which is CNN. You can see there is convolution 2D, max pooling, flatten, and lens. So for the max pooling is to reduce the dimension. So and then it will extract from input filter and the output max value of each channel. So for the flatten is to convert data to 1D array for input and to feed it to the next layer. For dense is a fully connected layer. Okay, next we will form the architecture, and we can see the data for max pooling, flatten, and dense. So after that is processing the input data. So the target size we set is 150 and the best size is 20. So at least we can see that the image belonging to 2 classes. So next we train the process. In this training we use epoch value is 20, the step per epoch is 20 and epoch is 10. And for the validation step, we use 1. So this is the data after we run it. So as we can see, the accuracy of training is, all of them is 100%. And for the validation, we can see that all of them is nearly to 100%. So this is the image in a graph. So the dot one is the training accuracy, and the line one is the validation. So this one is training and validation accuracy, and this one is for the loss. So before I proceed with the coding of the test image of the PET bottle and aluminum can, I will show the image that I take, which is for the first condition. The PET bottle and aluminum can is placed side by side, and for the second condition, the aluminum can is in the front, while the PET bottle is at the behind of the aluminum can in 10 to 15 centimeter. And for the third condition, which is opposite from the second image, which is the PET bottle is at the in front, while the aluminum can is at the back. So now I will show the coding for the testing for these three images. So for another task, for task 1 is to capture our own image for PET bottle and aluminum can. So for the task, firstly, we put the PET bottle and aluminum can side by side. So after that, the image will be processed, and we can see that the PET bottle and aluminum can is detected, and it's shown 100% for both of the object. For the second condition of the task is put the PET bottle behind of the can for 10 to 15 centimeter. So we can see that the aluminum can is 100%, while the PET bottle is 0%. So for the last condition is opposite from condition 2, which is the aluminum can is put behind of the PET bottle. So the result shown that the aluminum can is 0%, while the PET bottle is 100%. So we can conclude that the two different tasks for task 1 is successfully done by us, which is we obtain the graph for image that are obtained from Drive. So the second task is 3 different image of our own image of bottle and can. So now I will let my friends to present the next method.
Assalamualaikum and good day everyone. My name is Syahirah binti Razali and my matrix ID is CE170108. Now I am going to do an explanation on how to run the coding for VGG and Inception CNN model using Google Colab. First, this is the Colab notebooks that I had ran before. First step is connecting this Colab to our Google Drive, and then we assign the file directory. For the next step is we create train and validation directory. After we run this command, we will get this output, which it tells us both can and pet train and validation length. Next step is we import the important library such as TensorFlow, Cross Optimizer, Cross Preprocessing Image, Image Data Generator, and so on. Next step is we pre-process the input data. After we run this command, it will tell us the convolutional neural network for VGG16 model. As you can see here, this is the first convolutional layer, second convolutional layer, third, and so on. After that, it will tell us the total parameters for this architecture. I will be using sequential method as I am creating a sequential model. Why am I using sequential is because the model is arranged in sequence. After we run the sequential command, then we will get the trainable parameters. Next step is I use image data generator from keras.preprocessing. What is the objective of image data generator? It is to import data with label easily into the model. As shown in the output here, you can see it already assigned the classes of each image. Then we will train the image. This is the training process. In this step, I use 50 epoch and the steps per epoch is 5. From the last epoch reading, we can see that the accuracy is high. This is because it achieved 100% of accuracy. It is safe to say that VGG is a high performance of image classifier. Next step is we plot the graph. Plotting the graph is using matplotlib.pyplot, and this is the command. After I have run the command, and this is the result that I get. The second pre-trained model, we are going to use Inception V3. Inception V3 is a type of convolutional neural network that consists of many convolutional and max pooling layers. At the end of the layer, it will finally include fully connected neural networks. We can see the architecture of Inception V3 throughout this simulation. The steps are just the same as before, that we mount this Google Colab into our Google Drive, and we set the directory of our dataset image. And then we are going to create train and validation directory. Next, we import important libraries. These are the rescaling command. Okay, this step is we build Inception V3 over a custom input tensor. This is the command for this step. As I said earlier, the Inception V3 consists of many convolutional and max pooling layers. So, this proves that Inception V3 has got a very long convolutional layers and max pooling. After that, we can see that the total parameters, and it also tells us the trainable and non-trainable parameters. The next step is we start the training process. For this step, we use epoch 50, and the step per epoch, we set it for 20. This is the result. As we can see here, the accuracy of this module is lower than the other one, which is VGG, and the loss also slightly higher than VGG. Same goes to validation loss and validation accuracy. Then we plot the graph using matplotlib, just same as before. And this is the outcome of Inception. What can I say for this both VGG and Inception V3 CNN model is that the best CNN model among these two convolutional neural network, VGG has got a better and optimal model in compared to Inception V3. This is by analyzing both training and validation loss and also accuracy of the model. That's all from me. Thank you very much.
In conclusion, from the first task, we can conclude that the CNN can be trained and be used to identify the classification of recyclable materials, such as the can and the PET bottles we use in this task. In the task 2, we can see that the prediction results can be improved furthermore by transfer learning concept on a pre-trained level, in which we use the VGG16 and Inception V3. In the task 2, we can observe that the both pre-trained model shows a better training validation and accuracy than the untrained CNN in task 1. So when comparing the two models, we can see that the Inception V3 is the best model as it has the highest and consistent training accuracy and validation. Okay, that's all for me. Thank you.